Hello everyone, this is your tutor AB and today we're going to be solving an IB physics problem from the May 2019 examinations. This is a HL paper 1 question worth 1 mark. Let's get started. The escape velocity for an object at the surface of the earth is v escape. The diameter of the moon is 4 times smaller than that of the earth and the mass of the moon is 81 times smaller than that of the earth. What is the escape velocity of the object on the moon? Now, let's remember what is the formula for escape velocity. This is in your data booklet, but I highly recommend you memorize this to save time. V escape is equal to 2gm over r. Okay, so what are they asking? They're asking us to find it on the moon. So there's a neat technique to solve these type of questions where you use division. You divide the two expressions that you create and keep the one you want to solve for on the top. And what do I mean by this? You will see in a second. What's the escape velocity on the moon? Well, we can say the V moon is equal to the root of 2 times g, the gravitational constant, into the mass of the moon, which is 81 times smaller than that of the earth. So let's write the mass of the moon in terms of earth, or we could write it the other way for the second equation, but this makes more sense. So m divided by 81 over the radius of the moon, which we know is 4 times smaller than that of the earth. And the reason I'm saying radius is 4 times smaller, because if diameter is 4 times smaller, the radius also has to be 4 times smaller. So we can say r by 4, where r is the radius of the earth. We're writing the radius of the moon in terms of the radius of the earth. And then we have the escape velocity on earth, which is essentially just our standard equation, 2g m over r, because we don't have anything else for that and we've written everything. So what can we do now? Well, do you remember what I said at the start? We should divide the two expressions we have and keep the one we solve for on the top. You will see in a second why. Let's say Vm over Ve is equal to the root of 2gm over 81 over r by 4, this root extends, divided by root of 2gm over r. Let's then rewrite this, right? We can square both sides. We get Vm over Ve whole square is equal to 2gm over 81 divided by r over 4 divided by 2gm over r. This is actually a complex fraction, so let's work this individually and combine them at the end. So for the numerator we get, let's simplify it, we just take the reciprocal, so 2 times g times m over 81 multiplied into 4 over r. Okay, now that just equals to 8gm over 81r. Okay, that's the numerator. Then the denominator, of course, will stay the same because it's already simple. So we can just write that as gm over r (2gm over r), sorry. Okay, because it's already in the simplest form. So let's divide these two together, this expression by this expression. We get 8gm over 81r multiplied, we take the reciprocal, so r over 2gm. Let's cancel stuff out, r, gm, gm. So we are left with simply, and 2 gets cancel out 8, which becomes 4. We get 4 over 81. But remember, that's, even though it's here, that's not the answer. Why is it not the answer? Because 4 over 81, as we said before, is equal to Vm over Ve whole square. We still need to distribute this square back to this left side. So we get Vm over Ve is equal to the square root of 4 over 81, which is 2 over 9, and we need to write the escape velocity on the moon in terms of the earth, so we simply get V moon is equal to 2 over 9 V E. In this case, V escape from the earth. So that's our answer right there. Wait, sorry. Yeah.